Very good afternoon, Dons of India. कैसे हैं आप लोग सब? मोहम्मद शमी. People are joining. Govind Murari, heavy ray. Yeah. I was told many of my students messaged me that they are not in a position to attend online classes. Yes, true. So if you are attending the class, please attend completely and continuously. Kapil Dev अलग है, कपिल देव अलग है ना? चलो जल्दी जुट जाओ. तब तक कोई गाना सुनाओ. प्रणाम कपिल देव. प्रणाम चंदन. चलो आज हम वेरियस एफिशिएंसीज देखेंगे. उसके बाद अच्छे न्यूमेरिकल्स करेंगे पेल्टन व्हील. एंड आई रिक्वेस्ट एवरीवन टू कीप योर कैलकुलेटर्स रेडी. ओके, हमारे तौफिक भाई आ गए. तो थँक यू. तुम्ही खूप छान शिकवात. अजून काय साहेब सांगा. चलो रे महालिंगम. एक सॉन्ग सर, कौन सा? ओ माय गॉड. दिशांत खूप नाव तरी चालला पुढे स्क्रोल होत. मी काय वाचू आता? गैस पावर प्लांट इंजीनियर. अच्छा, एक का नाम देखो, क्या नमूने हैं. अच्छा, तू मिले दिल खिले. चलो 1 मिनट में हम स्टार्ट करेंगे अब. So we'll be starting in just 1 minute. So my dear students, my details are given on the screen. If you want, you can follow me. This is my referral code. I'm not forcing anyone to follow, but if you like, you can follow because you can watch my classes live or recorded classes. There is no problem. Chalo. Swami Reddy, Venkat Reddy, Rendran Reddy. Above. अम्फम इन बंगाल. क्या हो रहा है यार? भयानक तूफान. इज इट? मुश्किल है बेटा, मुश्किल है. जीना मुश्किल हो गया. हैदराबाद इज गुड एज ऑफ नाउ. इट्स गुड. पता नहीं अब आगे क्या होगा. वो सब ऊपर वाले की लीला और दया है. हम तो केवल वी आर जस्ट एक्टर्स. And the director is at the top. Whatever he directs, we have to act. वो जो बोले, मी ठीक है बेटा, तुम्ही कसा है? Your power plant notes. Yes, 2020 is becoming very worse. Okay, चलो अब स्टार्ट करेंगे. तो you can refer my code PK006 if you want. चलो आगे बढ़ते हैं. But number of tests are less in Telangana. That is the cause of concern. The number of tests are a bit less. That is the concern. Chalo, ab start karte hai. Now let's go to various efficiencies. And it's a humble request. No, it's around 23,000 tests. Only 3.5 crore people of Telangana. The strength is 3.5 crores, but number of tests are only 23,000, I think. I don't know, but anyway, government is doing well. Well, let's see how things move. Chalo. Now we'll see various efficiencies. There is a possibility of confusion in this. So let me remove your confusion. चलो, already we have seen, देखो बेटे, अब be careful. From nozzle and the inlet head is H. Please, no comments. Oh my God. From nozzle, the fluid is entering the runner. I'm not showing blades, all those things. This is the inlet to the runner. The runner is developing a power PR, and this we call it as runner power. Okay, this is runner power. From the runner, it goes to alternator or generator. And finally, this is my shaft power. Okay, runner say, ab dekhna, finally we have output power, shaft power. Finally we have shaft power. Okay, ab dekhna dhyan se. Ab cool raho aap. Now I request everyone to stay cool and enjoy the class. Stay cool and enjoy the class. Aram se, aram se. Okay, look at carefully. Dekho. Finally we are interested in, देखो, whenever he says turbine, it is the output power we are interested. This is nothing but your shaft power. Okay, no problem. Okay, now look at carefully. I'll give you a simple example. What is the input? Already I gave you. Power is equal to WQH. I have derived. Power is equal to WQH. This is the input head. So therefore, input power will be equal to WQH. Wait, input power is WQH. Now have a look at this. There is one device, okay, A. There is another device B. Let us assume that, मैं एक छोटा सा example दे रहा हूं. Let the input to A be P1. Let input to A is P1. Let A develop a power P2. Let A develop a power P2. And let B develop a power P3. No problem at all. B is developing a power P3. अब देखते हैं. What is the efficiency of A, my dear students? The efficiency of A is output by input, that is P2 by P1. Let's find out the efficiency of B. What is the efficiency of B? For B, this is the input and this is the output. So therefore, it will be output by input, that is P2. Let us find out overall efficiency. So if it is combined overall, so for overall, this is the input, and for overall, this is the output. Excellent, my dear students. ध्यान से सुनो बेटे. So can I write P3 by P1 as P3 by P2 into P2 by P1? Can we write? इधर देखना. P3 by P1 is P3 by P2 into P2 by P1. तो ये P2 जब cancel हो जाएगा, again you get P3 by P1, P3 by P1. So observe here. So what is P3 by P1? It is overall is equal to, what is P3 by P2? It is the efficiency of B. What is P2 by P1? Efficiency of A. So please observe, if you want overall efficiency, then it will be product of individual efficiencies. My dear students, yahan tak samajh mein aaya sabko? Yahan tak, please tell me, till now is it clear? You are not saying anything. Till now is it clear? So I'll move ahead. इधर देखना बेटे, अब देखना प्लीज, कूल रहो. This is the nozzle and the input is H. This is the head. So what is the input power? It will be WQH. WQH. So you know very well it is developing a velocity V1. So what will be the, okay, this is developing a velocity V1. अब ये कहां जा रहा है? It is going to runner. And runner is developing a power PR. Now I use one word, hydraulic efficiency. Before, अब देखो मैं हर एक चीज क्रिस्टल क्लियर कर रहा हूं. I'm making every point crystal clear, but one must have patience for this. Okay, can you tell me, my dear students, what is nozzle efficiency? We have seen very clearly for nozzle efficiency, it is output by input. Matlab, it is, I will write this as V1 square by 2G is output head and the input head is H. So therefore, this is my nozzle efficiency. Already this I had explained in my first class or second class, I don't know. Okay. Now, can anyone tell what is blade efficiency? कल बताया था. What is blade efficiency? This is the runner or blade. Runner or blade efficiency. It is the output. My runner, I want the blade efficiency. Where are blades? On the runner. So it is known as runner efficiency or blade efficiency. The runner is developing a power PR. So output by input. Input. What is input? Half M V1 square. Already we have seen this. My dear students, is it clear? Already we have seen this. Ab dekhna bete. I use one term known as hydraulic efficiency. Thoda careful raho. Now I use one term known as hydraulic efficiency. The problem with 40% students is they are taking these online free classes as casual. मतलब कोई टाइम पास के लिए आ रहे और जा रहे. But there are teachers giving their best. Whether it is it is M dot. Yeah, absolutely, it is M dot. देखो, hydraulic efficiency. Look at carefully. My dear students, always remember, please, no comments. Always remember, in impulse turbines, nozzle is also part of the turbine. We take nozzle also part of the turbine. I repeat, in impulse turbines, there will be nozzle because in impulse turbine, the fluid should enter the runner with high kinetic energy. So it is the nozzle which converts complete pressure into kinetic energy. So this is one unit. So what do you mean by hydraulic? Fluid action. इधर देखना बेटे, fluid action कहां से शुरू हो रहा है? मुझे बताओ. Turbine is मतलब runner, लेकिन impulse turbines में nozzle is also part of the turbine. तो हम ये दोनों को एक यूनिट लेते हैं. Listen, ये दोनों को एक यूनिट लेते हैं. We take these two as one unit. Now tell me, there is a fluid action. Fluid is entering in nozzles, pressure is converted to velocity, and that velocity is entering the runner to develop the power. So this is completely hydraulic or fluid action. क्योंकि ये सारा fluid का game है. Once the power is developed, fluid का कोई role नहीं है. That power is connected to the shaft and the shaft is developing power. So once the runner is developing power, fluid का कोई role नहीं है. That fluid will go. Now when देखो, let us say this is the runner. So on the runner we have blades. It is developing power. So once it develops power, it causes the rotor rotate. एक बार rotate होने के बाद ये किसको कनेक्ट करते हैं? Generator shaft. अब generator shaft से अब output power आएगा. वहां पे there is no fluid action. There is all mechanical action. Okay. So that's why for this the hydraulic action is input to the nozzle. Then you may be asking, sir, why are you taking nozzle in the turbine part? The reason is, in impulse turbines, we need a nozzle. Because of nozzle, Please observe, because of nozzle, my complete pressure is converted to velocity, and with that velocity, the fluid enters the runner blades. So therefore, this is the integral part. तो मुझे बताओ, hydraulic efficiency, मतलब ये पूरा hydraulic action, fluid is entering and power is developed. देखो, what is the output power? It is the runner power. And what is the input power? This head. अगर ये power है, तो this should also be in power. PWQH. And this is known as hydraulic efficiency. This is known as what? Hydraulic. Why do we call it as hydraulic? Because input is fluid action, and because of this fluid action, the power is developed. So iske baad, we don't use the word hydraulic. So please observe, hydraulic efficiency is output from the runner. Runner kitna develop ho raha hai? Runner kitna develop kar raha hai? PR. And what is the input that you are giving? Please observe. And don't say, sir, this is the input. अरे यार ये तो blade के लिए input है. मेरे complete turbine के लिए, for my complete turbine, for this complete turbine, I repeat, for this complete turbine, this is the input. And this is all fluid action. Because of the fluid motion only, the power is developed. That's why we call it as hydraulic action or hydraulic efficiency. What is hydraulic efficiency? It is the ratio of runner power. Already I have derived runner power as what? M dot into, कल बताया था, VW1 U1 minus VW2 U2. But in Pelton Wheel, U1 U2 are same. So take it out. So it will be VW1 minus VW2 into U1 U2 is same. But I should write this as plus or minus. Why plus or minus? All these I had explained yesterday. And please do not by heart. Today I'm going to do some questions wherein in one case it will be plus, in other case it will be minus. If a student is by hearting, then gone. So please tell me, is the hydraulic efficiency clear? आप कुछ नहीं बोल रहे. Is the hydraulic efficiency clear? बोलो रे बाबा. Is the hydraulic efficiency clear, my dear students? Hydraulic efficiency clear? Yeah. Now, अब देखना. Udaya Rasakunda. Oh. Okay. Now observe here. Please observe here. Understand carefully. Okay, hydraulic efficiency is over. Can I write? Please observe, my dear students. Hydraulic efficiency has two components. इधर देखना. देखो. This part is nozzle and this part is runner. देखो. So runner output, runner input. Runner output, runner input. You call it as what? Blade efficiency. So nozzle input, nozzle output, nozzle efficiency. But please observe, just now I gave you. So this overall hydraulic has two components, nozzle and runner. So can I write hydraulic efficiency is equal to nozzle efficiency into what I say, blade or runner efficiency? Abhi to bataya na. Just now I have derived. Overall, this bolo sirs, is it clear, my dear students? All of you, samajh mein aa raha hai? This is very, very important. Hydraulic efficiency is nozzle efficiency. फिर से बता रहा हूं, सुनो. This is the nozzle. This is the input. This is the output. This is the runner power. So this by this, output by input, this is blade. Output by input, this is nozzle. अगर आपको total hydraulic चाहिए, from this to this we call it as hydraulic. Hydraulic is equal to nozzle. Hydraulic is equal to nozzle into blade efficiency. All of you, have you followed? All of you, have you followed? Excellent students of India. Excellent. So what is the equation of hydraulic efficiency? The equation of hydraulic efficiency is runner power to the input power to the nozzle. Excellent, my dear students. Excellent. Up aayenge. Now, please observe here. Understand carefully. From the runner, देखो, from the runner, all of you. Okay. Overall ले लेंगे. And finally, thank you, Ankit. Finally, my dear students, you are not interested in runner. Runner is developing, but that is connected to a generator shaft, output shaft. So from runner, it should go to the output shaft. My dear students, my runner is developing PR. PR is runner power. Runner is developing PR, but that is connected to the output shaft. This we call. Always remember that in turbines, when he uses the word, the turbine develops 9,000 kilowatt. Actually, कुछ भी नहीं बोलता है. It is actually shaft power. When nothing is mentioned, it is actually final output shaft power. Understand carefully. It is actually final output shaft power. तो ये shaft power. इधर देखना बेटे. अब रनर से, अब ये रनर से कहां जा रहा है? शाफ्ट को. वेरी सिंपल. बेरिंग्स होंगे, बेरिंग फ्रिक्शनल लॉस होंगे. फ्रॉम रनर इट इज गोइंग टू आउटपुट शाफ्ट. तो अगर रनर 100 डेवलप कर रहा है तो रनर से आउटपुट शाफ्ट डेफिनेटली ये कम डेवलप करेगा, शायद 90. एंड these 100 is runner power, but finally you are getting only 90 to run the shaft. And these are known as mechanical losses. These are known as what? Mechanical losses. So mechanical efficiency is equal to, so shaft power by runner power. Mechanical efficiency is equal to shaft power by runner power. अरे यार, shaft से कहां जा रहा है वो? देखो, runner से shaft, तो फाइनल शाफ्ट को घुमाना है. You have to rotate the final shaft. So runner is developing 100, but for causing the complete rotation, definitely there will be bearing, friction, all those losses. So there will be a loss. So those losses we call it as what? Mechanical losses. So what is mechanical efficiency, my dear students? So please be clear, my dear students. देखो, this is nozzle. From the nozzle, it is runner. So runner is developing PR. I'll write very sequentially, don't worry. This is H and that power will be WQH. Very good. Now, then it is moving to nozzle. Nozzle से velocity V1 आएगा. अब वो कहाँ जाएगा? Runner. और runner develop करेगा PR. और runner develop करने के बाद ये देखो generator और जो है वो shaft. Let us say this is the shaft power. This is the shaft power. So finally we are interested in shaft power. तो ध्यान से सुनो, रनर से जो शाफ्ट को जा रहा है, these are mechanical losses. These are what? Mechanical losses. So therefore यहां से यहां, please observe. So now I write यहां से यहां, please let's draw this figure neatly. Okay, so mechanical efficiency, always remember efficiency is output by input. So देखो, this is the input to this device, this is the output. So output by input. PS is shaft power, PR is runner power. Very good. Now what is this? देखो, blade efficiency. What is blade efficiency? Blade is runner power, blade efficiency. ये blade है. Run output by input, half m dot v1 square. And if it is nozzle, my dear students, if it is nozzle, बोलो, if it is nozzle, v1 square by 2g, it is output head and inlet head is h. So ये यहां से यहां तक we call it as hydraulic action. यहां से यहां fluid है. Now there is no fluid here. I don't use the word hydraulic. There is fluid here. This is hydraulic. So hydraulic is equal to nozzle into blade. So hydraulic is equal to, for hydraulic, this is the output, this is the input, that is PR by WQH. Now observe here. So overall efficiency, already you know. Overall is, इधर देखना बेटे, overall final output, actual input. If this is in power, the denominator should also be in power. So final output is PS shaft power and the input is WQH. And this is the overall efficiency. So I can write overall is equal to, this is all hydraulic, this is mechanical, this is hydraulic, this is mechanical. So therefore it will be hydraulic into mechanical. But already in hydraulic we have nozzle, blade. Already in hydraulic you have nozzle and blade into mechanical. This is my overall efficiency. All of you, have you followed? अरे यार आप कुछ नहीं बोल रहे. All of you, is it clear? I'm very sorry, आप लोगों को आ रहा है या नहीं? All of you, is it clear? And some of you are attending casually, I know. Some of you are attending without any interest. All of you, is it clear? फिर से बता रहा हूं सुनो. Please listen, because this is the point where students commit mistakes. देखो, it is head H. अगर power चाहिए तो WQH. Okay, it is developing V1. So what is from here to here, you call it as nozzle efficiency. Here to here nozzle, and it will enter blades or runner mains, and this is developing PR. यहाँ से यहाँ, these are blades. It is blade efficiency. And these put together, ये पूरा we call it as hydraulic efficiency. यहाँ से now it is shaft power. So this is mechanical losses, mechanical efficiency. So this completely is overall. Overall can be written as mechanical into, ये दोनों लिए तो hydraulic आएगा, hydraulic. So अगर please observe mechanical, अगर hydraulic चाहिए तो it will be nozzle into blade. All of you, are we clear? All of you. All of you understand? See, what I mean here is generator se, please observe, generators, please understand carefully. You have alternator shaft here. Generators, please run from runner to run the shaft. Runner and output shafts are mounted. Yeah, Uday, I'm in class, special class. Yeah. Now, please observe. Runner is making the shaft rotate. From the shaft, we have final generator, final shaft. So please observe, these losses are mechanical losses. So finally, I say, what is hydraulic efficiency? It will be the runner power, hydraulic runner power by WQH. I repeat, my dear students, idhar dekhna. Hydraulic is this. So it will be runner output by WQH. And always remember overall efficiency. Can anyone tell what is overall efficiency? Final shaft power by input is WQH, where H is head at the inlet to the nozzle. अरे यार, are we clear? ये दोनों equations याद रख लेना. Please tell me, or I can write overall efficiency is hydraulic into mechanical efficiency. Do not worry, I'll come up with generator efficiency in my numerical. I'll remove that confusion if someone has. Shall we proceed towards a numerical so that you can understand things in a better way? All of you, have you followed? बोलो रे, all of you, have you followed? Shall we proceed? कुछ नहीं बोलते देखो. Shall I proceed? Very good. देखना बेटे. अब मेरा रिक्वेस्ट है, if you are attending, attend continuously and completely. Otherwise, don't come. चलो, प्लीज सुनिए. कभी भी याद रखना, पेल्टन व्हील में, सुनो, पेल्टन व्हील में मैं आपको कैसे हिट करना बता रहा हूं. How to hit the question I'm telling you. In Pelton Wheel, first the student should focus on absolute velocity at the inlet to the nozzle. First you should focus on V1. ये actually, from here only it starts. The first point from where you need to attack is calculating V1. कभी याद रखना, पेल्ट और गैस टर्बाइन्स में आपको क्या कैलकुलेट करना है? टेम्परेचर्स. When all temperatures are known, easily you can solve the problem. लेकिन पेल्टन व्हील में टारगेट कभी याद रखना, V1 को टच करना. एक बार V1 आया, उसका लिंक पूरा आ जाएगा. Once V1 is known, its link will come. Okay. Now, please observe here. Already in my earlier classes, पता नहीं आपको याद है या नहीं है, I gave you V1 is CV root 2GH. इसीलिए I tell to attend classes regularly. That's why I say to attend classes regularly. So this equation I gave already in my earlier classes of Pelton Wheel. Is it clear, my dear students? अरे यार बोलो यार, is it clear? बताया था मैं. बताया था this equation because I gave the link between nozzle efficiency and coefficient of velocity. याद है आपको? I gave this in first class. Thank you. In first class. देखो, if CV नहीं देता है, if CV is not given, take it as 1. If CV is given, take. If it is not given, take it as 1. V1 is equal to. Can anyone tell the meaning of V1? I said meaning of V1. It is the velocity with which the fluid is coming from the nozzle. It is known as jet velocity or spouting velocity. CV दे रखा है 0.985 under root of 2 G is. Keep calculators ready. Head देखो बेटे, already the head is given. आपको कुछ लग रहा है? हेड को देख के कुछ लग रहा है? प्लीज, लुकिंग एट द हेड, कुछ महसूस हो रहा है? I felt something just by looking at head. I told you Pelton wheel is a high head turbine. So for Pelton wheel, head should be greater than 250 meter. But यहाँ पे head 42 दिया है. Observe करना. And there are practical difficulties of using low head for Pelton wheel. But anyway, values are given. So let us take it. So can anyone give me the value of V1? Anyone? Correct है? Everyone ready? Be ready with calculators. 28.27 meter per second. Excellent. याद रखना. Okay, no problem at all. Please observe here. Find the runner power. All of you look at. Find the runner power. We know that the runner power is m dot into VW1 plus or minus VW2 into U. Already I gave this in my previous class, ये equation. ध्यान से सुनो बेटे. Please listen. Density is equal to mass by volume. Mass is equal to density into volume. Wait. अगर mass rate चाहिए, mass by time, it will be density. ये तो volume है. Divide with, अभी बता रहा हूं, volume by time. What is volume per unit time? Volume per unit time को हम बोलते हैं discharge. तो mass rate m by t is m dot is rho into discharge is q. Already discharge is given, इधर देखना. Already the discharge is given as 1 meter cube per second. So therefore mass flow rate is equal to, the fluid is water. So the density of water is 1000 kg per meter cube, and the discharge Q is 1 meter cube per second. So meter cube is gone, kg per second. So you will get a mass flow rate of 1000 kg per second. Look at, my dear students, look at the bucket speed. Bucket speed का मतलब blade speed, and that is designated with U. So the bucket speed is 15 meter per second. Look at, no comments. You know m dot. Yes, m dot. You know U. Yes, you know U. The only problem is VW1, VW2. No comments. The only problem is VW1, VW2. And if you draw triangles, my dear students, try to draw. In my last class, I told you V1 is equal to VW1. This is our U. I'm not writing U1, U2. And in my last class, I explained U1, U2 are same. So VW1 is equal to V1. Anyone? What is V1? 28.27. So there is no problem with VW1. There is no problem with VW1. Just now we have calculated. The only problem is VW2. The only problem is VW2. VW2. Have a look at this. Let me calculate. He gave, listen, my dear students. He gave jet deflection angle as 165. What does it mean? What does it mean? This is our beta 2. Because देखो बेटे, the fluid is entering and deflecting. So therefore, please understand carefully. This angle is 165. So this blade angle will be this blade angle beta 2. Anyone? What is blade angle beta 2? It will be total 180 minus 65, 165. So the blade angle is 15 degree. अरे बाबा, are we clear? Please, आपको लॉजिक समझ में आ रहा है? All of you, is the logic clear? Okay, nice, fine. Now, one more concept. Please observe here. देखो देखो. Let me try to draw velocity triangles. I do not know velocity triangle. मुझे पता नहीं है ये exit velocity triangle सही है या गलत है. I don't know. This is VR2. This is beta 2. This is U. Okay, fine. And already you know U is given as, देखो बेटे, what is U given? What is U given? Blade speed U, blade speed U, blade speed or bucket speed is 15. This is 15. Question. Let me calculate. एक बात बता रहा हूं. I have drawn a triangle. Honestly, I do not know whether my triangle is correct or not. मुझे पता नहीं है कैसे. I'll ask you one question. Please answer. Can you tell me this length? देखो, this is VR2. This is beta. Can I write this as VR2 cos beta 2? अरे यार, ये तो VR2 है. I want this. 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 देखो, तो let me calculate VR2 cos beta 2. अरे यार, this is VR2. Okay, let me calculate. This is VR2. ये opposite sign है, ये adjacent cos है. Let us calculate VR2 cos beta 2. All of you look at. In this problem, blade friction factor or blade friction coefficient is not given. So actually K is equal to VR2 by VR1. Yesterday I explained everything. When it is not given, it is logical to take this value as 1. जब नहीं देता है, we don't take friction and therefore VR1 is equal to VR2. Whenever it is not given, you take it. Now observe here. Can anyone in the class tell what is VR1 from this triangle? अगर आपको VR1 चाहिए, it will be V1 minus U. I repeat, if you want VR1, it will be V1 minus U. So VR1 is equal to, V1 is already known. Already we have calculated V1. What is V1? 28.27. And U is 15. So VR1 is equal to 13.27. But just now you saw VR1 is equal to VR2. Why? Because friction is not given. So you take it as this. Okay, fine. Very good. Now observe here. Let's calculate what is VR1 is equal to VR2. 13.27. So 13.27 cos 15. Let me calculate. Cos 15 into 13.27. कितना आ रहा है? 12.81. So this is 12.81. देखो बेटे. So this length is 12.81. This length VR2 cos beta 2 is 12.81. 12.82 हो रहा है. 12.82. This total length. But what is U? 15. Listen. What is U? ये कितना रहे दिया है? 15. Oh my God. So this triangle is absolutely wrong. Can anyone tell why it is wrong? Because ये तो 15 होना चाहिए. This is 15. But already this is 12.87. अगर ये 15 है, this should come out like this. So this will be my velocity triangle. This 15, ये 15 should be greater than 12.82. So my triangle is wrong. My triangle is wrong. So therefore, please understand carefully. Please understand carefully. That is the beauty of the question. Because if you by heart, this is my total U, which is 15. 15 is greater than 12.82. आपको समझ में आया? Please. आप लोगों को समझ में आया? Yes, it is third case. That's why students by heart. तो ये this is 12.82 and this is 15. So when I had taken the earlier case, actually that is not correct. So that's why you should not by heart. Now please observe, this is my V1, which is also VW1. Can you tell me the direction of VW1? The direction of VW1 is towards right. देखो बेटे, V2 has two components. V2 has two components. So this is my, now I write V2 ka, this is my VW2. This is my VW2. Look at the direction towards right. This is my VW2. Yes, and this is our VF2. V2 has two components. One is flow, one is whirl component. So can anyone tell what is VW2? इधर देखना बेटे. This total length is 15. This total is 15 and this is 12.82. So 15 में से remove 12.82, you get VW2. That is 15 minus 12.82, or VW2 can be written as VR2 cos beta, sorry, U minus, I will write this. So this can be written as U minus, this total is U minus VR2 cos beta 2, and that is turning out to be 2.18 meter per second. Can you tell me the direction of VW1 and VW2? VW1 is in the right direction. VW2 is also in the right direction. So don't use plus. When are you using plus? Minus of minus ho to plus hota hai. So now I use the equation runner power is equal to m dot into VW1 minus VW2 into U. I should use this equation. Please tell me, are we clear? Is the question clear, my dear students? अरे बोलो बेटे, please tell me, is it clear? नहीं यार आपको crystal clear. Thank you. So runner power is equal to m dot. Just now you have calculated 10 power 3 1000. Just now you have calculated m dot 1000 kg per second into VW1. Already VW1 is known 28.27. VW2 it is 2.18 and velocity U, blade speed is 15. Let us check the unit. Units are very important. M dot kg per second. M dot. VW1 minus VW, it is difference in velocity. So it will be again velocity. Difference in velocity is also velocity, meter per second. So velocity VW1 होगा और एक velocity है. Again this is meter per second. Now look at kg meter per second square. Kg meter per second square is Newton. There is meter by 1 second. There is this kg meter per second square is Newton. There is 1 meter second. Newton meter is joule. Joule per second is watt. This will be in watt. If you divide with 1000, you'll get the answer in kilowatt. You will get the answer in kilowatt. Anyone? So therefore, the runner power is कितना आ रहा है? 391.3 into 10 power 3 watt, or 391.3. 10 power 3 watt will be kilowatt. So we have calculated the runner power, and that is in kilowatt. Hope you have understood. Hope you have understood. Tawfiq, you gave wrong answer initially. The problem is not over. Abhi kya pucha hai? And he's asking hydraulic efficiency. So what is hydraulic efficiency? Already I gave you the equation. Hydraulic efficiency is runner power by WQH. Just now I gave you, and you have to be very, very, very cautious. How? If this is in kilowatt, this should also be in kilowatt. For water, the specific weight is 9.81 kilonewton per meter cube. I repeat, for water, the specific weight is 9810 Newton per meter cube, or 9.81 kilonewton per meter cube. And the discharge is meter cube per second, and head is in meter. So ये गया, Newton meter is joule, joule per second. Kilo Newton meter is kilojoule. Kilo Newton meter is kilojoule by second is kilowatt. Yes, if this is in kilowatt, this should also be in kilowatt. So hydraulic efficiency is runner power kilowatt में कितना है? 391.3 kilowatt by W. What is W? 9.81. Q कितना दिया है? already Q is given, discharge is given, Q दिया है 1 into head. What is the head? एक बार देखेंगे, head 42 meter. So therefore it is 42. This is also in kilowatt. Can you give me the value of hydraulic efficiency? कितना आ रहा है? 0.949, or if you want in percentage, it is 94.9%. All of you, have you followed, my dear students? Please बताइए बेटे, is it clear? अरे आप कुछ बोल ही नहीं रहे हैं. Is it clear? It's not overall, it is hydraulic. So overall की बात, okay, good. Now please take this question. Next question, आराम से करेंगे. Whatever we are doing, let's do it perfectly. Okay ना? चलो. Okay. A Pelton wheel is to be designed. The shaft power 9560 kilowatt, and the head is 350 meter, and the speed is 750 rpm. The overall efficiency is 0.85. The jet diameter, देखो, jet diameter means nozzle diameter. जिस diameter से fluid आ रहा है, this is the jet diameter, and that will impinge on the wheel. So the jet diameter is 1/6 of wheel diameter. 1/6 of wheel diameter. Okay. Now the jet diameter is 1/6 of wheel diameter. Find the number of jets, and CV is equal to point. ये अच्छा सवाल है sir, I'll do it. And CV is 0.985, and the speed ratio rho is U by V1. This is known as speed ratio. This is known as speed with ratio, and that is given as 0.45. Excellent. What is asked in this question? एक बार देखना. What is asked? Find the jet diameter, means small d. Number of jets required. Okay, number of jets required. चिंता मत करना, आराम से हम करेंगे. Don't worry at all. Okay, good. I told you very clearly, Pelton wheel का starting V1 से शुरुआत करो. The beginning of Pelton wheel should be with V1. V1 is equal to CV under root 2GH. I told you very clearly. So V1 CV 0.985 under root of 2 into 9.81, and the head. What is the head? 350. Can you give me the value of V1? Can anyone give me the value of V1? कुछ नहीं बोल रहा है. V1. अब है V1 का वैल्यू. It should be 81.62 meter per second. One more thing, the speed ratio is given. U by V1 is 0.45. So U will be equal to 0.45. U is 0.45 V1. So U is 0.45. V1 is 81.62. Can you give me the value of U? Anyone? U 36.73 meter per second. Stop, my dear students. I've told you very clearly the blade speed is pi dn by 60. Why are you taking capital D? Because my blades are mounted on this rotor, and this is my capital D. And if you want the speed U, it will be pi capital D n by 60. Can you tell me the meaning of capital D? It is the mean diameter of the wheel, not jet diameter of the wheel. So therefore, already U is known, 36.73. 36.73 is equal to pi. Capital D is wheel diameter, and speed n is given. What is speed n given? 750 by 60. And you will get the wheel diameter. Anyone with capital D? Anyone with capital D? Very good. 0.9. Very good, sir. I'm very happy with some students. But he is not asking wheel diameter. He is asking jet diameter. But in the problem, he gives the jet diameter is 1/6 of this. So therefore, it will be 0.935 by 6. So you will get small d. Anyone with small d? Point 0.155 मीटर 0.155 मीटर तो फर्स्ट पार्ट हो गया देखो नंबर ओके एंड ही इज आस्किंग नंबर ऑफ जेट्स रिक्वायर्ड एक सेकंड बेटे लुक एट लिसन this diameter is small d and it is coming out at V. Let us calculate discharge from single jet. Let us calculate discharge from wheel diameter is also asked. पूछा? Yeah, very good. Wheel diameter, jet diameter. ठीक है, no issues. If it is asked, no issues. Discharge, मुझे बताओ, what is discharge from single jet? Everyone knows discharge when you study fluid mechanics, it is area into velocity. तो कहां से आ रहा है देखो, it is coming out through this. It is coming out through this. It is coming out through this. So therefore, discharge from single jet. This is single jet. Pi by 4 d square. It is the area of the jet and it is coming out at a velocity v1. So therefore, from single jet, let us calculate, my dear students, from single jet. So therefore, now let's try to calculate from a single jet. Single, it will be area is pi by 4 d square into velocity v1. Pi by 4 and the diameter is already we have calculated 0.155. Please note down that the fluid is coming from the nozzle or jet. So you should take nozzle or jet diameter. So pi by 4, 155 whole square and V1 is already known to me 81.62. 81.62. Can you give me the discharge from single nozzle? 1.56. Okay, 1.56 meter cube per second. But he is asking number of jets. We have calculated discharge from a single nozzle. Let us calculate total discharge. How do you get total discharge? From total power. So who is developing that power? All jets put together is developing the total power. So what we do is, dekho bete, is the overall efficiency given? Yes. You know that overall efficiency is shaft power by WQH. Ek baar dekhna. When I use the word overall efficiency, it is the overall discharge. देखो, जब overall है, तो this will be overall or total discharge. Means, please note down that all jets put together, they are developing total power. This is the total power from all jets. So therefore, this will be the total discharge. So you know the total discharge, you know single jet से कितना discharge आ रहा है. So if you want number of nozzles or jets, तो एक जेट से इतना निकल रहा है डिस्चार्ज. टोटल डिस्चार्ज कैलकुलेट करो. सो सिंगल चाहिए तो टोटल डिस्चार्ज बाय सिंगल जेट. सो इट विल बी व्हाट इज द ओवरऑल एफिशिएंसी गिवन? ओवरऑल एनीवन? ओवरऑल कितना आ रहा है? ओवरऑल 0.85. ओके, 0.85 एंड द शाफ्ट पावर, एक सेकंड, 9560. If this is in kilowatt, this should also be in kilowatt. अगर kilowatt में चाहिए तो W should be in kilonewton per meter cube. You should be very very cautious. अगर ये kilowatt में है, this should also be in kilowatt. So for water it is 9.81 into Q. This will be the total discharge because it is the total power. And the head, what is the head given? Head कितना था? 350 meter. So 350 meter. So you are getting this discharge total as 3.22, I think, if I am not wrong. Okay, now 3.22. Single से कितना आ रहा है? 1.55. So number of jets will be equal to total discharge by discharge from single nozzle. The total is 3.22 and this is coming out to be 1.5. कितना आ रहा 1.55 0.1 second from single point. What is the discharge from single jet? 1.56. I'm sorry, 1.56. I think you are getting 2. I think you are getting 2.0 something. So number of jets are 2. Number of jets are 2. Please tell me, all of you, have you followed? अरे यार बोलो रे, आप कुछ बोल ही नहीं रहे. And I'm leaving one question. Sir, your secret revealed in TD a few lectures before Jantagar. What is the secret? Good food, sound sleep. Acha. Okay. So I think today I'll be sharing my RSC notes. ये question दिया हूँ. You take it as assignments. To develop more power topic. But I'll not use many because it may interfere. All these will be explained very in depth in our regular classes. These are special classes, okay? Understand? So please tell me, have you followed? तो ये assignment ले लेना. Take this as assignment and please observe. On Unacademy, this is my code. If you want, you can follow me. This is my referral code. It's up to you. Okay, na? And this is my mobile number. You can follow on this. ये मेरा नंबर सेव कर लेना so that मेरे स्टेटस आपको आएंगे. So hope you have yes, exactly, because to avoid interference of jet. All these I'll discuss in अच्छा Telegram channel पे share करना. All these I'll be discussing in regular classes, okay? Because ये क्लास में क्या है, एक सीक्वेंस नहीं, क्या नहीं पता नहीं, लोग आ रहे जा रहे है ना. ओके ओके. तो अभी हम टुडे वी हैव रेगुलर क्लास एट 8 o'clock RAC. तो I'll be coming up with many more. Thank you, Harry. तो Manendra, awesome class. Thank you. Please, है ना? Okay. You are simply matchless. Thank you. Francis भी करवाना है? Okay, कोई बात नहीं. आप जो बोले वो करेंगे. जो बोले वो करेंगे, लेकिन धीरे धीरे से, आराम से, है ना? So, एक कोविड का कब खत्म होगा? कोरोना वायरस कब खत्म होगा बोलो. आप बोलो रे. जनरली आई टेक स्पेशल क्लास एट 2 o'clock. जनरली वो मेरा कन्वीनियंट टाइम है. या क्या करें बोलो. टुमारो एवरी डे आई टेक. टुमारो कुछ नए. सी प्लीज यूट्यूब पे आई एम कमिंग विथ बेसिक्स ऑफ मेटल फॉर्मिंग. आई एम कमिंग. पेल्टन व्हील के ब्लेड से 30 डेली आई विल कम विथ या साइतेज आई विल डू इट. ओके ना. चलो तो सबको धन्यवाद. ओके, थैंक यू. I'll be sharing it on, so kindly save my number. तो आपको स्टेटस आएंगे. Hope you have enjoyed the class. Okay, thank you. I'll be teaching 9 to 11 subjects. ठीक है, चलो बाय बाय. कल मिलते हैं. चलो धन्यवाद. See, I have not explained velocity triangles here, but in my regular class I'll be taking 5 hours. 5 hours only to explain velocity triangles, because I'll be talking about different profiles, plate profiles. Centrifugal हो या axial हो, reaction हो या impulse हो. So, है ना? तो चलो हम मिलते हैं. रेगुलरली विल मीट. बनाएंगे शुभम दलवी. बहुत दिन हुआ जी आप नहीं आ रहे. Why are you not coming regularly, शुभम बाबा? मेरे नोट्स पूरे इंडिया में मिल रहा है, आपको नहीं मिल रहा? हाँ, चलो, गुड बाय, थैंक यू, गॉड ब्लेस यू, थैंक यू.